Let's go on and get started with today's lesson. Are there any questions over any of the assignments thus far? Any questions over anything we've done so far? All right, guys, let's find a seat because we're going to go on and start on the note sheets. So the first problem we're looking at is this one here. So we have 3x, guys. Let's focus up here. So this is the first problem we're going to be looking at today. 3x over x plus 1 minus 5 over 2x is equal to 3 over 2x. And we want to solve this for the value of x. Now the first thing we can do in solving any of these here is to go on and find the restrictions. See what values of x would make the denominator be 0. Now there's 3 different places where x could be 0. One of them is where the x plus 1 is. And the other 2 are where we have 2x and 2x. Now looking at this here, well, what would make x plus 1 be 0? What value of x? Negative 1, because negative 1 plus 1 would be 0. Then we would also need to look at the 2x and 2x. Well, in both of those cases, it would be 0. So the 2 values of x that can make the denominator 0 for this function here are negative 1 and, well, 0. So when we get the solutions for this here, the value of x cannot be negative 1 or 0. Because if we get either one of these values, that is a solution that will not work back in the original problem. Now what we need to do is find out what term or terms we need to multiply each one of these by so that the denominators will simplify out. So what do we know for sure that we need to multiply by? X plus 1 and 2x. Because if we multiply each one of these by x plus 1 and 2x, it will simplify out each rational expression denominator and make it a little bit easier to work with. So we're going to multiply each of these terms by 2x and x plus 1 so that each of the denominators will simplify down. Now when we look at the first one here, well, the x plus 1 and x plus 1 will cancel out. And the next one, the 2x and 2x will cancel. And the last one, the 2x and 2x will cancel. And now what that leaves us with for the first one is 3x times 2x. So 3 times 2 is, and x times x is x squared. Minus 5 times our x plus 1 is equal to 3 times x plus 1. So after we finished multiplying each term by 2x and x plus 1, we got rid of all the fractions, and we're left with 6x squared minus 5 times x plus 1 is equal to 3 times x plus 1. Now at this point here, we just need to solve for the value of x. And the first thing we can do in solving for the value of x is to, well, apparently scroll up, distribute the negative 5. We need to multiply through by the negative 5. So we get 6x squared. Well, negative 5 times x is negative 5x. And negative 5 times 1 is negative 5. Is equal to, here we're going to distribute the 3. Well, 3 times x is going to give us 3x. Stop scrolling. And 3 times 1 is going to give us plus 3. Now looking at this here, because we do have an x squared term, we need to get everything on the same side and it equal to 0. Because anytime we have a quadratic or higher, a degree 2 or higher, we need to get these equations equal to 0. Now the first thing we can do is what? We can subtract 3x from both sides. Because we'll need to get everything on the same side and we'll go towards the x squared. So if we subtract 3x from both sides, we get 6x squared. Well, negative 5x minus 3x would be negative 8x. Minus 5 is equal to 3. We subtract 3. because again, we need this equal to 0. So we need everything on the same side. So we would need to subtract 3, which would give us 6x squared minus 8x minus 8 is equal to 0. Any questions on any of this here or how we got to this point? We ready for the next part? Okay, now we need to solve. Now there's two different ways we can go about solving this here. One of them is we can use the quadratic formula, or we can factor it. Which way do y'all want to do? We can go on and factor it. Now if we're factoring, we first need to look for a greatest common factor, 2. That will go into all three terms, and 2 will go into 6, 8, and 8. So we'll need to factor it out. We need to pull it out, and it'll make it easier to factor. If we have factor as 2 out of 6x squared, we're left with 3x squared. Minus, if we factor 2 out of 8x, we're left with minus 4 is equal to 0. Then we'll have our two sets of parentheses with 3 spaces. Now the first thing we need to look at is the signs. Since the 4 is negative, our constant term 4 is negative, our signs are going to be opposite. One is positive and one is going to be negative. Now we need to find the factors of 3x squared. 1 and 3, and we'll have x and x. Do we want the 3 to be with the plus or the 3 to be with the minus? So we'll put it over here. And lastly, we need to find the factors of 4. Well, we have 1 and 4 or 2 and 2. Let's go with 2 and 2. Now if we check this here, x times negative 2 is negative 2x. 2 times positive 3x is plus 6x. And negative 2x plus 6x is a positive 4x. Is that the middle term that we wanted? Well, no, we need it to be negative, not positive. So what we can do is we can change the signs, flip the signs. And if we flip the signs, now we have x times 2 would be a positive 2x. Negative 2 times 3x would be negative 6x, which would give us a negative 4x, which we wanted. So we just need to switch the signs. Any questions on how we got to this point so far? Now that we have it factored and have the correct factors for this here, we do have two things multiplied together that equal 0. And whenever we have more than one thing multiplied together to equal 0, it tells us that one of these has to be 0. So either x minus 2 is equal to 0 or 3x plus 2 is equal to 0. One of these has to be 0. And at this point here, we just need to solve for the value of x to see which one of these will be 0. So in our first one here, what we can do is we can add 2 to both sides. And if we add 2 to both sides, these will cancel, telling me x is equal to 2. Now we'll do a similar thing for the other side. We'll subtract 2 from both sides first, because these would cancel. Telling me that 3x is equal to negative 2. Then we would divide both sides by 3, telling us x is equal to negative 2 thirds. Any questions on this here? Now, what did they say, or what did we find our restrictions to be? We said x cannot be what? Negative 1 or 0. Are either of our answers one of our restrictions? No. So both of these answers work for this here. So the answers for this are x is equal to 2 and x is equal to negative 2 thirds. And that's it. That's all we have to do for this here. Any questions on any of these problems here? Let's go on and look at the next one. Now this one here is a little bit different because the denominator for one of these is actually factorable, or x squared minus 1. So we can't just multiply this one by x plus 1 and x minus 1 squared. We have to factor the x minus 1 squared for us to be able to see what we actually need to multiply everything by. Now the x plus 1 in the first denominator does not simplify, but we do need to simplify the x squared minus 1. We need to factor it down. Now how would x squared minus 1 factor? Yes, because x squared minus 1 is the difference of perfect squares. So we'd have x minus 1 and x plus 1. And after we get it factored down, it'll help us define two things. One, it'll help us define the restrictions, and it'll also help us define what we need to multiply everything by. So if we're looking for the restrictions, we're looking for what value of x will make the denominator 0. Well, our x plus 1 here and x plus 1 here tell me that x cannot be negative 1, because negative 1 plus 1 would be 0. Now we also have an x minus 1 in the denominator, so 1, because 1 minus 1 would give us 0. So in this case here, x cannot be negative 1 or positive 1. We can't have it be either of these here. Now what do we need to multiply each of these terms by? Because they do both have an x plus 1, so we need to multiply everything by x plus 1. Do we need to multiply them by anything else? Yes, it would be. Because for all the denominators to simplify out, we need not only just x plus 1, we also need the x minus 1. Because if we multiply each of these terms by x plus 1 and x minus 1, well, in our first rational expression, the x plus 1 and x plus 1 would simplify out. In the middle, we would have the x minus 1 and x minus 1 simplifying, and x plus 1 simplifying out. And in the last one, well, the 3 doesn't have a denominator besides 1, so nothing would simplify. Now we need to see what we have left. In the first spot, we will have our 4x plus 1 times our x minus 1 is equal to 12. Because what we multiplied by, the x plus 1 and x minus 1, simplified out completely with its denominator, leaving us with just 12. Plus 3 times what? X plus 1 and x minus 1, yes? Where did we get that from? We specifically got it from the x squared minus 1, yes? So what should those two multiply back together to be? Because we could have rewritten it out as x plus 1 times x minus 1, and when we distribute it and actually multiplied it out, we would actually just get back to x squared minus 1. So if we do have both of the factors and know what they factored from, might as well just replace it with what it is instead of having to rewrite the steps back out. Any questions on this here so far? Now, unfortunately, the 4x plus 1 and the x minus 1, we don't have it factored down, so we'll need to actually multiply it out to see what it becomes. So here we can do 4x times x, which is 4x squared. We'll do 4x times negative 1, which is negative 4x. Then we can do 1 times x is plus x, and 1 times negative 1 is negative 1, is equal to 12 plus, here we'll distribute the 3. 3 times x squared is going to be 3x squared, and 3 times negative 1 would be negative 3. Now at this point here, we can go on and combine like terms. So we'll have 4x squared. Well, negative 4x plus x is going to be negative 3x minus 1 is equal to 3x squared. Well, our 12 minus 3 is plus 9. Any questions on anything we've done so far? Now, we do have a quadratic, because we have two different spots where we have a variable to the second power. So let's move those first and see if we still have a quadratic. So the first thing we can do is subtract 3x squared from both sides. 4x squared minus 3x squared would be x squared. Minus our 3x minus 1 is equal to 9, because these 3x squares would simplify out, because 3 minus 3 would give us 0, so they cancel out on the right-hand side. Yes, we would. Then minus 9 from both sides, because again, we need this equal to 0. So we get that x squared minus 3x minus 10 is equal to 0. It's equal to 0. Any questions on how we got to this quadratic, x squared minus 3x minus 10? Oh, we can go on and factor it, yes? So, 2 sets of parentheses with 3 spaces is equal to 0. Well, since the 10 is negative, it means our signs are opposite. One's going to be positive and one is going to be negative. Well, the factors of x squared are x and x. And the factors of 10 that we want are 5 and 2. Because 5 and 2, I think, would be the one that's most likely going to work. Which one would be positive? And 2 would be positive and 5 would be negative. And these would be the set of factors at work. Because if we multiply through, we would get negative 3x. Because x times negative 5 would be negative 5x. 2 times x would be plus 2x. And negative 5x plus 2x is a negative 3x, which is the middle term that we wanted. Now that we do have two things multiplied together to equal 0, it's telling me that one of these has to be 0. That's the only way we can get to 0. So either x plus 2 is equal to 0, or x minus 5 is equal to 0. Now we just need to solve for the value of x. So in our first case here, we can subtract 2 from both sides, which will tell us that x is equal to negative 2. In our next case here, we would add 5 to both sides. And if we add 5 to both sides, we get x is equal to 5. So our two answers for this here are negative 2 and 5. Now we said the restrictions were what? I'm going to rewrite them down here so we can see them. Negative 1 and 1. Well, are either one of these our restrictions? Nope. So that means that negative 2 and 5 are both of the solutions for this here. Both of these values of x will work. Any questions on any of this here? Are we ready for the next one? Yes. I mean, all the problems we've worked with so far, the extraneous solutions haven't been too important. but most likely we'll need to find them for this one here because I think the extraneous solutions will come into play. What do y'all think? Yep, because it kind of tells us, doesn't it? Kind of told us in the instructions. So we will have an extraneous solution come out for this one here, but the process that we do with these here and the ones we just did aren't going to change. So we will still need to factor the denominator, so especially the middle one, the x squared minus 9, will need to be factored. Now the x minus 3 is fine, and the x plus 3 is fine, but we do need to factor the x squared minus 9. Now if I factored x squared minus 9, what would we get? And it will factor this because x squared minus 9 is a difference of perfect squares. And I think y'all kind of like how difference of perfect squares factor. Not too bad. Now our restrictions for this here would be what? So we would have 3 and negative 3, because for our x minus 3 and x minus 3, well, 3 minus 3 would be 0. And for the x plus 3, well, negative 3 plus 3 would also be 0. So these here are restrictions. So if we get a value of x that is 3 or negative 3, we know that it will not work. So we can't have either one of those values. So let's go on and start with solving this here. So the first thing we need to do is figure out what we need to multiply each term by so that the denominators will simplify out. So what do we need? An x plus 3 and an x plus 3 and x minus 3. We'll need both of them. And each one, the x plus 3 and x minus 3, appears only once in each denominator. I mean, the middle one, we have one of each, but we don't have any of the denominators that have x plus 3 more than once, or x minus 3 more than once. So when we multiply, we only need each of them once. And we can also see that when we go through and simplify, here the x minus 3 and x minus 3 would simplify out. In the middle, we have an x minus 3 and x minus 3 that cancel. We have an x plus 3 and x plus 3 that cancel. And lastly here, we have an x plus 3 and x plus 3 that cancel. And we have them all that matched up. Now, do we have anything left in the denominator? Well, no. So that means we found the right thing to multiply each term by. If I ended up having something left over in the denominator, well, I can add that in by multiplying each of the terms by an extra one. Now let's see what we have left. On the first one, we have 6 times x plus 3 is equal to 8x squared minus 4x times x minus 3. And this is all that we have left here. After multiplying everything by x plus 3 and x minus 3. Now at this point here, we do need to distribute or scroll. So distribute the 6 and distribute the negative 4x. So if we distribute the 6, well, 6 times x would give us 6x plus 6 times 3 is 18 is equal to 8x squared minus, well, negative 4x times x is going to be negative 4x squared And negative 4x times negative 3 is going to be plus 12x. Now at this point here, we can combine like terms. Well, not with the 6x plus 18. But the 8x squared minus 4x squared would give us a positive 4x squared plus 12x. Any questions on this so far? Now we do need to get everything onto the same side of the equal sign. So the first thing we could do is what? Well, we can either subtract the 6x from both sides or subtract the 18 from both sides, or we can do both at once. Either will work. So we get 18 is equal to 4x squared plus 6x. Then we would also need to subtract 18 from both sides because, again, since we do have an x squared term, we need this equal to 0. So we'd get that 0 is equal to 4x squared plus 6x minus 18. Any questions on any of this here so far? Now the last thing we need to do is we need to factor this to be able to solve. Yes, I would look for a greatest common factor, and there is a greatest common factor of 2 that will go into all three terms. If we factor 2 out of 4x squared, we're left with 2x squared plus 2 factored out of 6x is x minus 9. Now we need to finish factoring this here. Well, I had a feeling it was going to scroll eventually. 2, and then we would have 2 sets of parentheses. The 9 tells us that the signs are going to be opposite. One is going to be positive, and one is going to be negative. Now the factors of x squared are going to give us x and x, and we'll use 2 and 1. Now the factors of 9 that we would want to use would be either 1 and 9, or which one would we prefer? 3 and 3. And if we did check this here, well, we would need to switch it. 2x times negative 3 would be negative 6x. 3 times x is plus 3x, which would give us a negative 3x. So we do need to switch the signs, yes. So we would have this be positive and this be negative. And this would give us the correct sign. Any questions on how we factored this? Well, the last thing we need to do is set both of these equal to 0. So we have 2x minus 3 is equal to 0. And x plus 3 is equal to 0. Now we just need to solve for the value of x in both cases. For the first one over here, our 2x minus 3 is equal to 0. We would add 3 to both sides, which would tell us that 2x is equal to positive 3. And last but not least, we would divide both sides by 2, telling us x is equal to 3 halves. Now what would we do to the other one? We'd subtract 3 from both sides. So x is equal to, now what did we say the restrictions were? 3 and negative 3. Did we get either one of these restrictions? So we can cancel that out. We can cross that out. Because if one of the restrictions shows up, it means it does not work. It's an extraneous solution. We call it any solution that we get from working the problem that does not work in the original problem what we started with, an extraneous solution. It's an extra solution that doesn't work. So here, the actual solution is 3/2. So the nice thing with finding the restrictions first is that we didn't have to take both of these and plug them back into the original problem to make sure they actually worked. The restrictions let us be able to see that just by looking at this here. Any questions on this here? Let's see where we're at. So we have a little over 10 minutes left of class, but we're going to go on and stop here because for kind of two main reasons. One is I think we could probably get through it, but it might be a little rushed, so it's not bad leaving it off till tomorrow. Also, this headset, or not tomorrow, but whenever we're back in, we'll do that. Also, the headset that I'm using to record this is dying. And the reason I know it's dying, I don't know if anybody's been hearing a little beeping noise. That's coming from these here trying to tell me that it's about to die, so. We're going to stop.